Hello and welcome to this episode of the Primary Maths Podcast, the show where we talk all things primary maths. I'm John Cripwell, and today we are digging into something that I am particularly passionate about, which is problem solving in maths. Not just as a tick box in a lesson plan, but as a skill that challenges how pupils, teachers and schools think about maths. And I am joined today, I'm delighted to say that I'm joined today, by somebody I know quite well, who lives and breathes problem solving himself, the brilliant Phil Hurd. Phil comes with over 18 years of classroom teaching experience. He spent 7 years as a maths lead, years as working in senior leadership as well, and like myself is a primary mastery specialist with the Maths Hubs too. And now he works across the Transform Trust, supporting teaching and learning across schools, particularly in, well, I know that there's lots of conversations, particularly in maths. So welcome, Phil. Thank you for joining us.
Thank you very much for inviting me along, John. I'm looking forward to the chat today.
Excellent. So I always start, Phil, with just a quick sort of recap of your journey in maths, I suppose. What was maths like for you at school? Was it a subject that you enjoyed or less of a...
So I always enjoyed maths, and I was always good at numbers, and that kind of that remains to this day. So mental calculations, I'm pretty efficient, shall we say? But I always did enjoy it. And then I remember when I went into secondary school, I got put in the top set, and then on the very sort of first or second assessment that we did in year 7, I think it was about 24%, which is about 40-50% less than everybody else. And I remember just sitting there in a heap, in a puddle of tears in this lesson, just because of, I wasn't as good as I thought I was, really.
Yeah.
And as a result, I got moved down to the second set, and that was fine, and I did very well, but I never quite understood. It was very procedural, and I was very good at procedures, but I never really had that deep conceptual understanding of what was going on in the background. So when it came to my GCSEs, my maths teacher sort of said to me, you have a decision to make. You can, really work hard to try and understand those concepts and go for the higher paper and get a chance to get an A, or you can take the foundation paper and pretty much be guaranteed a B. And to this day, I've always been, I'll take the easy life and get a B, thanks.
Yeah.
And then, so and that happened, but I didn't necessarily, I didn't enjoy. Sorry, I didn't get as much out of maths as I perhaps could have done. And then going into my A level, I wanted to do statistics, which was a reasonably new A level at that point. But because it was a new A level, my parents didn't necessarily understand its value.
What was the thinking there, Phil? What was your master plan with doing statistics at A level?
It was just that I enjoyed doing numbers and maths, but I realised that I wasn't kind of good enough for A level maths, as it were. So it was just a chance to continue doing some kind of maths. And I've always been interested in kind of data and kind of research and that kind of thing. So I felt that would have fitted at the time as well into what I was kind of enjoying. But unfortunately, I got persuaded against it.
Right.
And that came back to bite me a bit, because I did a lot of economics at university, and kind of some of the statistical analysis stuff that I would have done in the A level would have been very handy. So yes.
And then after, was it economics that you did at uni?
Yes. And then
awesome. Okay.
And then I did when I got into teaching, and when I did my PGCE, I went down the English route because I'd done English language at A level.
Yeah.
And then in around 2010, I had this notion of perhaps doing a master's degree. And I spoke to my head teacher at the time, and I knew that she had done a master's part-time whilst working and having a family. And although I didn't have a family at that point, it was, I was aware that doing it part-time might take me a while. And so I asked for her advice, and she sort of gave me some advice. And then a couple of weeks later, she left on my desk a leaflet for what was the math specialist course that had came out of one of the curriculum review or the curriculum reviews around 2010.
Yeah,
So I got enrolled on that, and that was 60 credits towards a master's, and it just kind of snowballed from there. And then from there, got involved in the Maths Hub and been riding the maths train ever since.
fantastic. Yeah, I did the maths specialist teacher qualification as well back in the day. I think mine was through the University of Derby, but from the University of Northampton.
Yes,
I
yeah,
think something like
yeah.
that.
So I did it through Nottingham Trent, but it was Nottingham, it was Northampton that were the awarding body. And
That's right.
interestingly, my wife is a maths teacher, and I came home from kind of the first. It kickstarts off with a residential weekend.
Yeah, I think that was the first time I had the pleasure of meeting Debbie Morgan. Actually, that residential. I think she did the keynote speech possibly on the first night.
Yeah, and I came home sort of buzzing about, oh, there's this new way of teaching maths, and my wife just looked at me and said, "You what?" I said, "Well, there's just concrete resources, and she said, "Yeah, that's just what we do." It's
Yeah.
it's it's not what we do, because up to that point, I started teaching in 2001. So for that first 9 years of my career, it was still very procedural uh, in terms of and there were some there were obviously got some resources out, but it wasn't as big a thing as it is now.
No, and there's definitely been a continual change, hasn't there? I think over the last 10, well, I mean, we're talking 15 years since you did that course and I did that course. Um, but I do think I do remember when I then went on to do the mastery training, teaching for mastery training with the maths subs, thinking how closely aligned it was to the stuff that we'd done on the maths course, and
Yeah,
it wasn't quite the 5 big ideas, but there was definitely the fundamentals, the foundations, I think, of the 5 big ideas that were contained within that. You can definitely see their sort of evolution from that point. So yeah, so then you've obviously done some work with the maths hubs, East Midlands West maths hubs, and then your role at the moment, Phil. What does that sort of encompass?
yeah. So I suppose I'm part of the kind of school improvement team, for want of a better phrase. It's not a phrase I like, because I'm not suggesting for a moment that the schools need improving, but
Yeah,
we're always striving to kind of I suppose it's the idea that we're all trying to get better at everything. Yeah. So and I oversee maths and computing for the trust. The maths has definitely been was my sort of founding principles, my touchstone, and we've tried to instigate elements of the mastery approach. We've tried to instigate things that I learnt on the maths course all those years ago, and just trying to make sure that good teaching is happening, on a daily basis for the children, because the children we serve in our schools, there's a lot of deprivation. It's mainly inner city schools, and maths and now computing, they are two kind of vital components to allow children to have greater success in life, far beyond their school life.
yeah. It's one of the things we often talk about, isn't it? That the purpose of learning maths isn't necessarily just to learn maths and be good with numbers and things. It's about problem solving, particularly, which is what we're going to talk about this morning. So thank you for
Absolutely.
that handy little segue. So let's address that then. First of all, we know problem solving is one of the 3 aims of the current national curriculum, along with reasoning and fluency. But I think there's maybe a little confusion out there, certainly with teachers that I speak to, about what problem solving really is. And I think one of the things that we see quite often is that problem solving is just the application of something that we've learned in a lesson. So we'll learn this new thing possibly in a lesson, whether that's multiplying fractions or whatever, and then we will do some problem solving with it later. Is that how you see problem solving? I'm not saying that's how I see it, but is that how you see problem solving, Phil?
I,
Put you on the
it,
spot.
well, it's how I see the understanding of problem solving being
Yeah,
amongst the profession, but actually, it's not how I see problem solving at all.
I
You
didn't
know,
think it was.
it would very, it's very much. I mean, I've got there was I did some training on this for our teachers recently, and I had a nice pithy quote, but actually it comes down to using what we know to work out what we don't.
Yeah,
And it was the difference between routine problems and non-routine problems. Now, routine problems being those that you know the method already going in, so effectively it's just a procedure, and this is where kind of the idea of word problem falls down, because 9 times out of 10 you've just done 3 weeks of addition, and then
yeah,
we're going to do some word problems, and lo and behold, they're addition word problems. And children therefore know the method. They've just got to find the right numbers. But actually,
yeah,
there's no struggle for some children in that, because they know the method that they need to be able to answer that problem. So yes, it's very much going at, so you then have these non-routine problems where you go into it not knowing the method that you need to be able to answer it.
yeah. And I think you're right. I think that's another good point, actually, just to touch on briefly, is that I think problem solving often gets completely conflated with word problems. And when people talk about their pupils struggling with problem solving, I think often it's what we're thinking of is word problems there. And as you say, maybe out of context word problems as well, the sorts of things that you get in a SATs paper or something particular. Although when you look at a Key Stage 2 SATs paper, the majority of the problems in there aren't necessarily word problems, are they? There's a lot of problem solving potentially in there, in the reasoning paper I'm thinking about,
Yeah,
but not necessarily word problems.
no, absolutely. And the SATs papers have now caught up with the aims of the curriculum. So back in 2018, I think it was 17, 18, there was a kind of a new curriculum assessment stuff well, we obviously had curriculum for 2014,
Yeah,
and then it was around 2017, 18 where I felt that the papers caught up with that way of thinking.
yeah.
And I agree wholeheartedly. I think now there's some really nice problem solving questions in there. And if I may try and describe one of my new favourite one from last year's paper, and it's an equilateral triangle.
So some teachers are going to get PTSD flashbacks from this, we
Well,
realise,
yes,
but
and
we
actually,
apologise.
this is an easier version of one that appeared a couple of years ago as well. But there's an equilateral triangle that is split into quarters. One of those quarters is further split into another set of quarters, so you have effectively a 16th.
Yeah,
And one of these little triangles within the quarters is coloured in, and the question is what fraction is shaded in. It is just a quarter times a quarter.
yeah,
And I make the conjecture that if that appears on paper one, which is just straight arithmetic, you're probably looking 85, 90% of children in year 6 would be able to get that right. But when it's presented in that way, again, I've not seen the figures, but I'm going to take a stab in the dark that actually it is a much lower percentage of children who are able to get that right.
yeah. I'd agree. Yeah,
And it's because, and this is one of the things I say to the children. So when I'm with a small group of children prior to SATs, just before they're about to take that paper, I sort of say to them, none of the maths in this paper is difficult,
yeah,
but what is difficult is working out what the maths is.
yeah,
And I
yeah.
think that's where problem solving at the minute is going slightly wrong.
And that's a great example. I do like that question. It's a great example of where it's not language that's tripping us up here. It's not trying to find the maths in amongst a jumble of words. It's the actual conceptual understanding, isn't it, of
Yeah.
how what a fraction of a shape might look like. And when I compare that to another favourite question that I know is a favourite of a colleague of ours, Tom Isherwood, and I've also used with some initial teacher training students recently, was the one from a few years ago about collecting eggs. So that
Yes.
was a word problem. And when you look at the maths in that word problem, if people are unfamiliar, it's something along the lines of.
I can read it here for you, John.
Can you? Oh, okay. You
So
just always have that prepared.
yes. So it says, in March, Ken collects 2, 3, or 4 eggs each day from his hens. In the first 20 days, Ken collects 57 eggs altogether. There are 31 days in March. What is the greatest number of eggs Ken can collect in March?
Which sounds, it's a lot of words, isn't it? And it sounds sort of complicated, but actually they give you a lot of information. So we're not even testing whether children know how many days there are in March there, which might have added to it. But otherwise, it's just figuring out what we know, isn't it? And then a relatively simple calculation. I think it's something like year 4,
Well,
maybe year 3
no.
work.
So actually, the reason I have it to hand is because I used it last week in the staff meeting with some colleagues, and one of the things I asked them to do was to work out in which year group they would encounter they would first encounter the necessary maths.
Yeah.
And one question that they have to do is 31 take away 20. So
Yeah.
that's a year 2 problem.
Yeah.
They then have to do 11 times 4, which I suppose is year 3.
Yeah.
But then you also had 57 add 44, which again is a year 2 problem. So although they are key stage 2 SATs, what make it a key stage 2 question, or even a year 6 question, is the deciphering what maths you need to do.
Yeah. Yeah. And it goes back to that question that you just talked about with the triangles and finding a 16th of it. Do you think, and we'll get into this more in a moment perhaps, but do you think it's because of the way that we still teach? So when I think back to how I taught multiplying fractions, I definitely started with what is what are we talking about when we're finding a quarter of a quarter, and that whole idea of multiplying is finding lots of. So that's a really fundamental concept, isn't it, that we move away from quite quickly. I think we get away from that idea of multiplication being repeated addition and shorthand for repeated addition, and we move towards it being its own sort of construct, I think, in a way. And I think sometimes children lose sight of the fact that 3 times 4 is 3 lots of 4. And that's fine until you get something like this where you're thinking, okay, what does a quarter times a quarter really mean? Well, it's a quarter of a quarter. So I definitely taught that with, we do folding paper and lots of ways of trying to show what a quarter of a quarter is, but it's quite abstract, isn't it? In some ways. So the procedure is really easy. And
Yes.
So you can do the procedure. We multiply the numerator by the numerator and the denominator by the denominator, and hey presto, there's your answer. And so in year 6, when time is precious, I can imagine that's where we maybe skip over some of that conceptual stuff, and we might, with best intentions, start with it, but then move quite quickly onto actually here's how you do it, because we've got this arithmetic paper with 36 questions or whatever, and this will definitely come up, and you just need to do this, and then you can move on to the long multiplication that's going to take you a little bit longer. So I'm not sure what my question here is, Phil, but that's kind of how I sort of see the problem, I suppose, is that there are the two sides. And as you say, from your own experience at school, we can be very good at the procedural stuff without necessarily understanding the concept that lies beneath it.
Yes, and I mean, I think you're absolutely right. And perhaps one of the reasons why eventually teachers just become not exasperated, but we just say, okay, let's just do this procedure, becomes down to kind of accountability measures. When we have a situation where you need children to score around 55, 60 marks, if you can get 35 of those marks on paper 1 by just doing the procedure, then and actually, is that happening at the expense of real deep understanding for the children? And I would argue that yes, we probably are doing a slight disservice because we're not giving the time to allow the children to explore, and make those connections that are necessary.
So this is so the curriculum and assessment review is sort of gearing towards a new national curriculum all the way through primary and secondary. And one of the things that it's suggested and that the government has said that it will take on board for when this new curriculum is published in 2027 is that they're not going to take any content out of primary, but it or certainly out of key stage 1 to 3. But it will be resequenced, and I think the indication is that some things might be moved slightly into key stage 3 to try and have a look at that kind of journey from key stage 1 to key stage 3, or all the way through to key stage 4 more cohesively, which I think makes a lot of sense. But it doesn't look like we're going to get huge amounts more time to teach this thing. And I know that's one of the things that we've talked about a lot when we look at other jurisdictions and different places around the world that do this stuff very well. There's a lot less in their early curriculum, and a lot more time is spent sort of mastering these conceptual things that we've talked about. So it doesn't look like that's necessarily going to free up a lot of time for us. So how do we, because problem solving has been a problem, if you pardon the pun, for decades, let's be fair. And certainly when I first started teaching, we used to do fun Fridays where we would have problems from Enrich often, but also just, I remember one where I set up a car boot sale type thing. We were doing percentages. I think the kids had coupons for percentage discounts and stuff like that. And that was kind of problem solving, because we realized that problem solving was an issue even then, back in the midst of time when I started teaching. How do we move towards a place where this is possible, that we can teach this depth of understanding whilst also, as you say, we've got these accountability measures saying you've got to get so many marks at the end of key stage 2, otherwise the school's in trouble?
One of the big things I think we need to kind of be aware of in our schools for this to provide this opportunity is that if we look at the year 1 curriculum, and if we accept as a basic premise that most schools are using one of 3 schemes, either Power Maths, White Rose, or Maths No Problem, all of those in year 1 have roughly 29-30 weeks of teaching.
Yeah.
So yes, you will need to spend some time. You'll need to do a second lesson on any through the year. But that's still going to leave plenty of time, I think, to develop a proper sequence of problem-solving lessons within your curriculum. Now, even the most jam-packed of year groups, which I think is year 5, still has only 34 weeks of teaching-ish.
It never feels like that, though, Phil, does it? It does. It never feels like there's all this time available.
No, and we all, which it doesn't matter which year group you teach in, perhaps except for reception, you always hear that, oh God, why didn't they know this? That this should have been taught last year, and and I'm sure the foundation teachers have their equivalent of, oh, why have they not experienced this in or whatever. But we keep saying this thing, and as you say, this has been a problem for decades. This is that plaintive cry of, oh God, why don't they know this problem? That basic fact when they should do. We keep doing the same things and expecting different outcomes.
Yeah,
and so things, things like, for instance, something simple like area of a rectangle, for instance, which is, I think, in the year 4 curriculum, but actually, if we just taught that as part of multiplication and division, if you have a rectangular area model being shown when you do multiplication, then that lesson can become very short, in due course. Oh, do you remember how we do this and why that? And so, and I think we just need to be a little smarter in kind of making those connections to sort of free up time along the way as well, and actually concentrating on those objectives. And this is what the NCETM did with their ready to progress criteria. And I was hopeful that would form the basis of the curriculum. That would form the basis of the new curriculum when this curriculum review was done. But as you say, it doesn't look like that's going to be the case. But actually, the ready to progress criteria are those that have the biggest impact across the range. So, so if you can spend a bit longer on those and do some problem solving in those, then you're going to have a wider impact across.
Do you think? Yeah, I can see your point there entirely. There's a little bit of a tension, isn't there, between how we used to teach maths, where we would do a week on multiplication and then a week on division, and then we'd do a week on percentages, and then at some point during the year we'd come back to another week on multiplication, and it was all a little bit broken up. Now we've moved to generally move towards a system where we spend a lot longer going into more depth on a particular topic. But are you suggesting that time is perhaps a little bit too siloed, in that it's quite a narrow focus often on those small steps, and actually there's opportunities to bring other things into those weeks that we spend perhaps on multiplication?
Yeah, absolutely. I think what we have got is the small steps in any of the schemes are almost seen as the holy grail, because the national curriculum is, I'm doing a hand gesture here for those of you listening, is this
Not
big?
a rude one, don't worry, it's fine.
No. So, but yes, it's, the national curriculum is yay big, but actually the small steps are even bigger because they break down each of the national curriculum objectives into sort of maybe 3 or 4 steps. So they are taken, well, that must be the sequence, that must be, and what that's done is it's taken away, not the need to think, but the, staff perhaps, teachers are perhaps not thinking as clearly about whether this next step is indeed the next step, rather than, somebody, so it comes back to teachers owning their planning and saying, they've got it, so I'm going to move on to this step. But they haven't got it, so I'm going to just go back and do that step. And eventually, you would hope that the teachers would say something along the lines of, "Yeah, my children are really confident with this. Now is the time to put in a bit of a non-routine problem, so that they then have to do." And it's perhaps no, after you've done a 3-4 weeks unit of addition. Is it worth doing an addition problem solving, regardless of what it is? Because they know that's the whole idea is that it's a problem that they don't know the method for. So one of the things I've advocated for, as we go back to, you mentioned Fun Friday. All maths lessons should be fun. So
I totally agree. Yeah, I cringe when I think back to my first few years of teaching. The number of times that I said things like that, where I think, well, that's undermining everything that you believe.
But I'm looking at sort of, is that an approach that we can come back to? This sort of once in a while, just putting in some non-routine problems. And one of the things I've sort of advocated for with our schools is that they pull material from Enrich, for instance, from the previous year group, so that the children, they have the maths available to them. There's no point setting problem solving, because that's also a new way of the children thinking. So there's going to be the cognitive load on that. If they then have to struggle with the math side of it as well, you're always going to struggle. So I've sort of said, right, if you need to go back a year or two for the problem solving,
As they do in the SATs, as we
Yes,
mentioned earlier.
absolutely. And it was interesting. If I can recount one anecdote of an Ofsted lesson that I was party to, it was a year 5 lesson on common multiples.
Yeah.
And the teacher had set up this lovely initial task where it was a disco. The red light comes on every 3 seconds, the
Yeah.
blue light every 4, the green light every 5. How many seconds will it be before they're all on at the same time?
Lovely. Yeah.
And at the end of it, the Ofsted inspector said, "Oh, well, it's a year 5 lesson. Can you explain? I think it was too easy because the numbers that were chosen were 3, 4, and 5." And I just I sighed and I said, "Can I just explain why you're wrong?" And and I did. And as the great philosopher of our time, Brian Clough, once mentioned, we had a discussion and we agreed that I was right.
Yeah.
So, but but uh, but but when you're faced with accountability measures where nuance like that isn't picked up on,
Yeah.
all of that goes together along with the SATs and all that to sort of make problem solving a bit of an anomaly, really.
Yeah. And just to touch on that lesson, which sounds great, by the way, there's the maths in that is quite tricky, even though, as you say, it just sounds like, can you find a multiple of 3, 4, and 5, which a common multiple of 3, 4, and 5, which doesn't sound that tricky. But actually, to really understand, without, I suppose, if you'd have said, here are these 3 lights, and what we're doing today is finding a common multiple of 3, 4, 3 numbers, and that gives you the key, doesn't it? But actually, to set that up and not give that clue to start with really requires some thought then about how. And I imagine if that had been me as a pupil in that class, I'd have been writing down my 3s and 4s, and then suddenly probably had an epiphany at some point, thinking, oh, okay, it's my times tables. I can do this. I don't necessarily have to write them all out.
Well, what was
Um,
interesting, so a lot of children did just start writing out their times tables and looking for the numbers
yeah,
that appeared in all 3. But then you had a couple of children who just went, well, if I do 3 times 4 times 5, I'm going to get an answer. But the
yeah.
question was, what is the
Is that
first
the
time?
yes? Yeah,
And so it was then we were able to sort of say, can you now convince me that 3 times 4 times 5 is the first time that those lights will come on together? And, so that mathematical rich discussion about, conjecture, convincing, reasoning, argue, so that child, those few children then had to put together an argument as to why, yes, it was or no, it wasn't.
and there's so many nice things in there, isn't there? I was talking on a previous episode about times tables with Kate Fern, and she was talking about that, very simple understanding that a number wouldn't be in the 5 times tables if it didn't end in 5 or 0 potentially. But how sometimes that falls apart when we go above 12 times, is 83 in the 5 times table? Well, no, because I know that the 5 times table only goes up to 12 times 5. So that sort of, rather than thinking, well, no, because I know that it doesn't end in 5, and we're spotting patterns. That sort of lesson that you were just talking about there, I'm just thinking about, if I can start with 3 times 4, which is 12. Oh no, that's not. I don't have to write out my 5 times table, do I, to know that 12 isn't in the 5 times table, so that's not going to work. And I know whenever we ask teachers, teaching assistants, parents, whoever, what we want a good mathematician to look like, one of the answers is always resilience. And being able to not give up at the first hurdle, as it were. And problem solving, I think, is I think one of the slight potential downfalls of a teaching for mastery approach is that we do go quite slowly through it for depth, which is really important. But you mentioned a word earlier, Phil, which was struggle, and I think that's important as well, actually. And sometimes if everything is laid out for us without having to think about it too deeply, then we don't have that element of struggle, do we?
No,
And you're not going to then build resilience.
and I think we've probably all taught those children for whom procedures and numbers and calculations come fairly easy, and
Yeah.
then the first time that they
That
are
was never me, by the way.
the first time they are then challenged on to either to explain their thinking or to how did you work that out, or are you sure? Is there another way? And it's that they immediately their defenses are raised, and actually, you don't ask those questions in a combative way or
No.
it's just says, oh, is there another way? Or are you sure? It's like, come on, let's explore. Let's and there's many children, as I say, for whom calculations are fairly straightforward, but then there will come a time when their calculations don't work, and have they had that opportunity to develop some of the other skills? And it's interesting that you sort of mentioned when you ask people what they do, and I don't want to give him too much credit. He's already had one name check on this podcast today. Tom Isherwood. He does an activity where he asks people exactly that. What are the characteristics of a good mathematician? And people shout out all kinds of answers, and he writes the answers in 2 lists. And one of the lists is very long, and it's things like resilience, collaboration, reasoning, communication, da 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 da. And then on the other side is a very short list that says something along the lines of can do a calculation. And actually, that being able to do a calculation is it's just almost such a small element. That's the final piece. And I think that's where we go wrong, is that we see that as the be all and end all, that, and actually that's first, foremost, and everything. But actually, no, that final calculation. And if we look at that, think back to that triangle problem that I described earlier, or the egg problem, the actual calculation is just the cherry on the top at the end. And to be able to get there, you need to have gone through the process of working it all out, and that's the bit I think at the minute we're still kind of missing.
And it's interesting what you say, that there will come a time when your conceptual understanding or lack of conceptual understanding causes a problem. And I think that just happens at different times for different people. So for some children, that might be in Key Stage 1. For other people, I know, talking to people on this podcast, somebody like Pete Mattock, who was a secondary maths teacher and excellent mathematician, but when it came to A-level maths for him, that was suddenly a completely different language and completely different approach to maths, and that was where he found that actually his lack of conceptual understanding of some things, was his sort of, not his downfall. It's not overly dramatic, but it suddenly became aware of what he didn't know, I think, and so being aware that will happen at some point gives greater impetus, I think, for teaching these things in a way that does make sense. The other point that you touched on there was these skills that we talk about that are slightly less tangible skills than what's in the curriculum. The curriculum lays out this knowledge that we should know. I do feel that we've moved away from some of the skills actually that maybe are fundamental to that knowledge. And as you say, knowledge will take you so far, won't it? But I always think, okay, if I don't know 3 times 4, but I do know how to work out 3 times 4, I think the knowledge of how to work out 3 times 4 is more important than just being able to know the product of 3 and 4. Knowing that is important because it helps us to reduce cognitive load and things. But I do think that if you've got the skill of being able to find it out, as you say, the thing that you mentioned right at the start, knowing what to do when you don't know the answer, or knowing what to do to find a way through it when you don't know the answer, is maybe a more important skill than just that pure knowledge.
And interestingly, I had a discussion with a pupil a couple of weeks ago around it was just a straight up calculation. It was a paper 1 practice kind of thing, and the question was 9 times 50. And this child had put 450, And I said, "Oh, yeah." And actually, I could see that the class had, I think they'd got a dozen questions to answer in 10 minutes as a bit of practice. And I could see that this child had finished in about 30 seconds. So I went over and had a chat with him. I said, "Oh, how did you work out 9 times 50?" And he said, "I just knew it." And I said, "Did you really?" Because 9 times 50 isn't a known fact.
No,
And, and then I had a discussion.
nobody does their times tables up to 50.
No, that's it. And I said to him, "Can you explain to me what you did?" And because you didn't just know it, I sort of said,
Yeah.
and eventually we got to the idea that, well, he knew 9 times 5, which I accepted as he probably did.
Yeah.
And then he just added a 0. So I had a discussion about just adding zeros with him. But fundamentally, that's what, he understood place value and did it that way.
Yeah.
So then I said, okay, I've done it a different way. And I just wrote on my piece of paper 500
Yeah.
and then 450. And I sort of challenged him. I said, right, what do you think I've done? And, he's then, it took him a couple of minutes to sort of, okay, you've multiplied by 10 and then you've taken one lot of 50 away. And I didn't do it that way. I did it the same as him, but I was just being,
Yeah.
I was just playing devil's advocate. And being able to have those discussions around, and this is where, the kind of greater depth, is being able to say, okay, well, there's that method, but which one's more efficient? Which one's going to work? Which one's not going to work in this given situation? And even a question like 9 times 50, which could be, very kind of procedural, or, there is
Yeah.
still within there opportunity for discussion, which will allow, and the discussions that you have with those children will be of benefit when they then come to do kind of problem solving.
Yeah. And we talk a lot about oracy these days and the importance of articulating your thoughts. And I think that's a great example of where that is, as you say, something that could very easily be brushed over and not given much thought to, but really does, as the teacher, reveal the conceptual understanding underneath what's going on when the child just says, "Well, I just knew it." Well, nobody, as you say, nobody just knows 9 times 50, do they? But you can very quickly get to it if you have a solid understanding of place value and of how multiplication works. And then what you very cleverly did, Phil, was check that his understanding of a different way of arriving at the same conclusion, that shows an ability to think around the problem, doesn't it, in a different way. So yeah, those questions are very useful, I think. So just to sort of touch on, because this has gone off on tangents, which I am liable to do, but the things that you've sort of advocated for so far, looking for opportunities to elicit discussion and thinking about thinking and all that metacognitive good stuff that we talk about quite a lot. Looking for opportunities to spend a session on exploring, and maybe we could touch on that briefly in a moment, if that's okay. I know time's against us, but exploring non-routine problems in a dedicated problem-solving session, and looking for opportunities to draw different areas of the curriculum together and make connections between them within lessons when teachers are planning. Is that a fair sort of summary of
Yes,
your kind of approach?
absolutely. Yeah, absolutely. Yes. And happy to explore any of those further.
Yeah. I mean, the thing about the connectedness of maths, I think, is really important, because I definitely saw maths as a set of discrete procedures to memorize, and I was rubbish at memorizing them. And therefore, maths was really hard for me, because every time I looked at something, I was starting afresh with it, rather than seeing that actually it was probably very similar to something I'd done before, just posited in a different way, or at slightly different numbers or whatever. So I wholeheartedly ascribe to the idea of, when you are planning a lesson, and lesson planning is something we've talked about a lot on the podcast. Think of, if you want to go back, if you're listening, you want to go back and listen to Lewis's episode where he talks about collaborative planning and the method for collaborative planning. John B talked about task design and the importance of really thinking through the tasks that we give to pupils, and I think that would be a good listen as well for this. And then this is the final time I'm going to name check him because he's had way too many, but Tom Isherwood as well also talked about the importance of lesson planning, and thinking outside of the scheme, using the scheme as a sort of place to hang on your actual lesson plan. So we know that lesson planning is really important, and we need to move away from this idea of the lesson is already planned because we're using a scheme. So let's go into the fun Fridays, as they were. This idea of, I know that what you're not advocating for here, Phil, I don't think, correct me if I'm wrong, is just getting a load of random problems from a website and putting them out on the table and saying, have a go at these. Or are you?
No, and I don't know if there's a statute of limitations on these kind of things, but that was definitely my approach at one point in my career, and I was quite fortunate as I was working in a school. It was a large primary school, 4 entry, and I was given the top set year 5 for 3 or 4 years, and I was able to just pull up a problem from Enrich and tell them to crack on. And we would discover and enjoy it, and I used to describe it as monkey maths, because you'd get 2 minutes into a lesson or 5 minutes into the lesson and you'd hear a child go, "Ooh, ooh, ooh, ooh,"
Yeah.
just because something had twigged and something. But that was an exceptional few years where I had some particularly engaged mathematicians. So yes, whilst I am now poacher turned gamekeeper, that's not something I advocate for now. But I think what happened so we had Curriculum 2014, and one of the things that national curriculum then said, as you say, was reasoning, problem solving, and fluency reasoning, problem solving, and they were this kind of the aims of the national curriculum. But what happened was all the schemes then turned round and said, "Oh, well, we've got problem solving baked into everyday lessons every day." But what that doesn't allow is for the teaching of explicit skills of how to go about solving problems. Now, there are a whole heap of strategies, and I was reading. I was reading something. I'm gonna have to find it later and perhaps edit this in, John. But it was saying, you can't just go about teach. You can't be almost discreetly teach those skills. You have to kind of have those discussions and teach them along. You do need to teach the skills of drawing a picture, making a table, spotting patterns, and all those. And I think now we have definitely lost the explicit teaching of problem solving skills and strategies. And I think there is a place for teaching those skills discreetly. Now, whether that is every Friday as it used to be, and we had problem solving Friday, or whether it's at the end of a unit, or whether you do it once every couple of weeks, I think that's up to schools to kind of try and work into their curriculum. But I definitely think there is a case for finding non-routine problems. Now, the difference to the olden days where you would just go on to Enrich and find it, or create your own, I think what you need to do now is to look and say, okay, this is where my children were. As I say, I would advocate for doing it on something that that they are good at the maths of it, so then they can spend their brain power trying to solve the problem. So, you're then thinking, right, they did this last year, I know they're good on it, so I'm going to use this problem, or we did this a few weeks ago and I just want to revisit. And one of the things I think is vital, and you mentioned the planning side of things, is going into that lesson with you having done the maths and having done all the possible, try and found all the possible ways around it so that you can make the links. It's a topic about fractions or decimals, and I remember one lesson, where I asked two children to, they were given a problem, it was a year 6, and it was like, which is bigger, 2/3 or 3/4? And every single child in the class was turning it into twelfths. And
Right.
and I was like, well, and I asked these two children who I were told were the highest attaining pupils, and I said, can you do it without turning them both into twelfths? Thinking they might put it on a number line, they might turn it to a
Yeah.
decimal or to a percentage or whatever, and they were stumped, and uh, they have this opportunity. So we need to give them the opportunity to explore reasons and methods and have them explain what they do.
Yeah, it goes back to another thing that we talk about quite a lot, which is what do we value most in the lesson? And if the answer to that is the answer, which obviously is important in maths, not going to downplay that it isn't, but if that's what we value more than anything else when we're teaching, then that becomes the sole sort of aim of the lesson, doesn't it? And therefore, those children that can just give you an answer very quickly have that initial success and never need to delve any deeper into it.
I
Um,
think I think you're absolutely right. And actually, what we need to do, is rather than have the answer being what we want from that math lesson, what we need to do is to think, okay, what I want from the end of this lesson is that the children have learned.
yes.
And if I think about my own maths experience, more so in recent years, as I try and whenever I do any kind of training, because it's mainly primary school teachers, I started off by doing, and I was very Key Stage 2 orientated. So a lot of my problems when I was talking to staff were Key Stage 2 based. I then got rightly pulled up on it by our Key Stage 1 colleagues. So I then started putting in Key Stage 1 problems, and Key Stage 2 colleagues. So I ended up saying, right, we're going to do Key Stage 3 and Key Stage 4 problems, because then you're all unhappy with me. But as a result, I had to then get my maths up to speed. And what tended to happen was I would get it wrong. I would then go to Mrs. Hurd and I would say, why is this wrong? And she would talk me through it. And it was from getting it wrong that I learned it, not because I practiced it 5 or 6 times and got it right every single time. I did it once, got it wrong, got told, and oh yeah, that's where I can see where I went wrong. Just maybe did one more practice, and that's it. So yes, I think what we need to do is reframe the aims of a lesson to be the children need to learn rather than they need to get the right. And that's not just teach. That's probably more so the children, that they probably have this perception that if I get the right answer.
Yeah, I think you're right. And where do they get that perception from? Well, probably teachers, but also parents, and culturally, when we're doing maths, one of the things about maths is that 9 times out of 10 it does have a very definitive correct answer at the end of it, and if you're doing a test and you put all the correct answers, then you pass the test. So you can't get away from that, can you? It's not like in English, although yeah, I've got my own issues with, for instance, the reading paper in year 6 in English, with its definitive right or wrong answers. But that is one of the things. It's one of the things that people like about maths quite often, is that I know that I am right because this is the answer. You can't, it's a fundamental principle. But I do think that there's an opportunity to, as you say, sort of reframe as teachers are planning the lesson. What is it that I want them to get out of this, and it isn't the right answer. It's, I want them to notice something, I want them to learn something, I want a connection to be made that wasn't otherwise. What is the purpose of it? It can't just be for some kids to get it right and other kids not to get it right, and
Well,
that's not.
Yeah, and I think there is a lot of times where it is, you could almost predict which children will get it right, which ones won't.
Exactly.
And then you go to the end and it's like, oh yeah, no, they didn't get it. And it's like, right, okay, so, we're expecting it. So let's make sure that we do something to negate it.
Yeah. And that is a frustrating thing, isn't it? As a teacher as well, you do kind of know that some children aren't going to get it, and yet there doesn't always feel like there's a enough time to properly plan forward for those things. But maybe that's an experience thing as well. I
I
don't
mean,
know. Maybe it gets easier.
what's interesting, we've had a push, and I mean, and this is perhaps a controversial opinion, but it might get you some extra subscribers. But it's this idea we've had this push on greater depth, and but actually, I feel that isn't greater depth.
No.
We've been misplaced, and actually, and but again, this might just be an experience thing. If I have a child who has understood a problem quickly, I can keep them going all day long. I can deepen their understanding all day long. If I have pitched the lesson too high, so that 10 of my 30 children haven't got a clue what's happening, I cannot on the fly make that easier for them. I have to get that making it easy for them from the start, from the planning stage, and the greater depth. I don't think I think what we have is this idea that greater depth is a scale score on the SATs paper, and actually,
It's getting everything right. That's
yeah,
great to do.
and
Yeah.
and I know from experience of children in my family that it's possible to be greater depth without being greater depth,
Yeah.
and that's one of the things. It comes back to this time thing. Oh yes, we don't want the greater depth children to be bored. Well, no, then no. Let's
Yeah.
really deepen their thinking. Let's not worry about moving on to the next concept, because there's still plenty more we can do with this concept.
And that links straight back to it's not the answer. That's not what we're not valuing the answer. Just because they can give us the answer really quickly doesn't mean that they have totally understood it. It just means that, just like that pupil that you were talking to earlier with the 9 times 50, yes, they had one way of doing it, but it took them a couple of minutes of thinking to figure out the different way of doing it, and the prompt that you gave them opened that opportunity for them, which otherwise wouldn't have necessarily occurred. It's not necessarily an organic thing, is it? I've got the answer, therefore I'm going to find a different way of getting the answer. That's not generally how we work, is it? So it takes some planning, as you say, and the teacher's role in that discussion is vital. Otherwise, it's not likely to just occur.
No, and I will have made very little difference to that one child because it was one question on one day. But
Oh, don't do yourself down, Phil. It was a life-changing moment.
But if we've got that kind of culture and those kind of questions happening in our classrooms
Yeah.
every day, then those opportunities and those connections will be made.
We are pretty much out of time, and I know you're a very busy man. But I've really enjoyed this discussion, and it's prompted me to think a little bit more about how we actually teach problem solving. I'm not sure we've completely solved that equation this morning, but I do think it's something that we can come back to. So just to recap then, making connections across different areas of maths, introducing non-routine problems where children are secure with the maths within the problem, but it's constructed in an unfamiliar fashion, and not something that they've just spent 4 weeks learning either.
Yeah.
Looking for opportunities to question more deeply and check for conceptual understanding. And as you say, perhaps having those sessions where we can introduce, and I know this phrase is going out of fashion as well, but those sort of low threshold, high ceiling type investigations where we can think a little bit about how am I actually going to access this problem, and I guess find a use for all these pictorial representations that I've learned over the years. Are any of those actually going to help me here?
Yeah.
Because that was always a frustration for me. We'd spend a long time with bar models and part whole models and lots of different ways of representing stuff, and it would come to the SATs, and you'd be looking through the papers afterwards when you were doing practice or whatever, and there were very, very few of those that had actually been employed in figuring out the problem. So much so that whenever I did find one, I used to take a little photo of it and celebrate, because that's what gets me excited. But yeah, I suppose if again, it's another one of those things where if we're holding their hand all the way along, we're going to draw this model today, you're going to then copy that into your books. You don't get the chance to actually think about when you would use it,
Yes.
do you?
Yeah.
So that might be another opportunity. Having these non-routine problems in a dedicated session might be an opportunity to just say, okay, well, have a go first. And I was always, I used to quite like, I'm not sure about teaching through problem solving necessarily, but I did used to like starting a lesson with a problem that we were unfamiliar with, working through it together. But again, I think that's different from what you're suggesting, which is actually we'll start this cold, but something that I know you can do the maths, but not necessarily the problem. But we can work on it together. You can work on it collaboratively. We've got those opportunities for conjecture and generalization and all that good stuff. But finding time for that in the curriculum or in the teaching sequence.
Yeah, you're absolutely right, because I've just found that the article that I kind of was basing a lot of my thoughts on, it was by Colin Foster. He was professor of mathematics at Loughborough, mathematics, and he was talking about all these strategies. Drawing a picture. You talk about the bar model, for instance. There, it's not enough to just say to the children, "Oh, well, can you draw a diagram?" And they've been given 15 different diagrams over the last month. So how do they know which one to pick? And it may even not be enough to say, can you draw a bar model? Because, you've got a bar model that shows that you can do for addition, subtraction, multiplication, division, and they all look slightly different, and then ratio and all that. So you've got to then think about your use of questioning. Can you, and guiding them to the right one, without necessarily, as you say, holding their hand right up the garden path to it.
So much to think about there, Phil. I know me and you actually we're going to do a little bit of work on problem solving this year. I would love potentially for us to come back and have another conversation about this maybe towards the end of the year and see whether we've got any further with how we can make this work in classrooms. But I really appreciate. Oh, go on.
I was going to say, once we've got a solution to the problem, all this, we can.
Yeah, once we've solved this conundrum, which I'm sure we'll be able to do in a couple of months.
Once we've got a book to sell,
we will write that book and we will sell it, absolutely. But thank you so much for your time this morning. I really, really do appreciate it. I'm sure you've given the listeners a lot to think about as well.
No problem, and thanks for inviting me on. And yes, happy to meet again at some point to discuss what we found.
Brilliant. Thanks, Phil. For the listeners, I hope you've enjoyed this episode. As ever, if you've got anything that you would like to add to the conversation, you can email me at primarymathspodcast@twinkle.co.uk or find me on any of the social media platforms pretty much. Just send me a message on there. I appreciate everybody that does, and I know that there will be things from this episode that will have got people talking. So absolutely get in touch and we will discuss some of those on the Aftermaths episode on Friday, when hopefully I'll be joined by Becky. So once again, thank you, Phil, and for everybody else, have a good week and I will catch you up on Friday.